Today I'll do one vector operation. So here is the problem. For simple shearing flow with velocity only in the x direction, that is ux is given, gamma dot y and uy and uz is equal to 0. So please calculate the vorticity, that is nabla dot u, and the deformation rate tensor d, and the rotation tensor omega. So we know that vorticity nabla dot u, so we know. So if with that two vector, if I do the cross product, okay, so it will be like that. So that will be I j k, then ux uy uz, and then vx vy vz. So component. Now here nabla is nothing but dou by dou x I plus dou by dou y j plus dou by dou z into k. Now when we do that cross product, so it will be like I j k. Okay, so now dou by dou x, dou by dou y, dou by dou z, and component of velocity, so ux uy uz. So that we are putting here. So now here in that problem, so ux and uy and uz is equal to 0, that is 0, that is 0, and ux is that is given gamma dot y. Okay, so that is that del or nabla cross u is nothing but this determinant of this. So ex uy and ez is nothing unit vector, and rate of deformation, the formula is d. This is the tensor half of nabla u plus nabla u transpose, and rotational tensor is omega is equal to half of nabla u minus nabla u transpose. Now first we have to calculate the vorticity. So now vorticity, so we know this is the vorticity. Now we have to calculate the determinant. So now here we are going to calculate here. So now here expanding the determinant. So ex into d, this will be we are going to calculate ex into this. So dy into 0 and dz minus dz into 0 dx. So now here this will be minus, and uy into dou by dou x of 0 minus dou by dou z gamma y. So as here this is the constant, not function of z, so that will be 0. So this will be 0, this will be 0, this will be 0. And now here ez, so now ez, so this and this will not be come into the picture. So ez dou by dou x into 0, dou by dou x 0, dou by dou y gamma dot y. So now here that is the function of y. So now if we do that differentiation, so we'll get that only gamma dot. So now that vorticity will be del dot u, so that is minus gamma dot ez. So that we'll get. Now we have to find out rate of the deformation. So now for that we have to know the diagonal product. So if there is a two vector, if we do that just simply AB, so it will be like that, a1 b1 a1 b2, like that. You have to remember that formula. Yeah, transpose will be like that. Okay, so b1 a1 b1 a2 b1 a3, like that. Similarly, if we do that, so nabla u, so that is the nabla u, so we will get this total formula, dou u dou x, dou u dou y, dou u dou z, everything, and here that transpose will be like that. Now here we know that ux is nothing but gamma dot y, and uz and uy is equal to 0. So now here, so now ex is only function of y. So now here, so this term will be 0, this term will be 0, so this is nothing but gamma dot, and all this term will be 0. Okay, 0, this term will be 0, this term will be 0. So that tensor will be 0 gamma dot 0 0 0 0 0 0 0. This is the deformation, rate of the deformation, or not, sorry, this is the nabla dot u. Now transpose, so if you do that, so only this will be gamma dot and rest of the term will be 0. If you do that differentiation, you will get that. So ultimately you have 0 0 0 0 0 0, sorry, this is gamma 0 0 0. And now finally if you want to calculate, so nabla u plus nabla u transpose, so now if you add, so you will get what? So that will be nothing but half of, okay, 0 gamma 0 gamma 0 0 then 0 0 0. Now if you do here, so that will be half of 0 gamma 0 then minus gamma 0 0 0 0 0. It will be like that. That's it. Thank you.